You have to figure out at point D, the camelback, the velocity first. Now, in order to solve for the velocity, you have to follow a couple rules of uniform circular motion. Remember, I told you here that Fn equals 0. Remember, that's your apparent weight is going to be nothing. I don't want you to feel anything. I want you to feel weightless as you go through there. So the only force acting on you here is Fg. Now, because it's a camelback, it is a curve, there is a radius to it. What that radius is, that radius needs to be somewhere between 10 and 30 meters. You pick what that is, you get to decide. Here, you're not picking the apparent weight, you're just picking the radius. Since you're moving in uniform circular motion, there's a curve at the top. Your net force, centripetal force, has to equal all the forces acting on you. There's only one, Fg. Oh, and it's pointing towards the center of their circle, so it's positive Fg. So this will be mg. This will be mv squared over r, the formula for uniform circular motion, centripetal force. The m's cancel out. You're going to solve for v, and that's how you get the velocity at that point, using the radius that you picked. Once you have the velocity, well, you can solve for kinetic energy at point D. Now just remember, up here, you're off the ground, you have some amount of height, but you also have velocity. That means you're going to have both. You're going to have total mechanical energy here that's made up of kinetic energy at D plus potential energy at D. You can find the kinetic energy by doing 1/2 times that mass of 50 times whatever velocity value you got here. That gives you KE. You can plug that back in here. The total mechanical energy, that's the same as your potential energy at point A. It's also the same as your kinetic energy at point B, or the combination of kinetic and potential at point C. But that number equals these two put together. So plug that in. You know these two values. And you can subtract this kinetic energy at D from the total, and that'll give you the potential energy. And once you have the potential energy at D, which is equal to the total mechanical energy minus the kinetic energy at D, you can use that potential energy at D to equal mgh, solve for height. Now you know the height.